everyone, and in this video we're looking at summer 2019 paper 42 question number 6, which is related to electric field. So the first part says state what is meant by electric potential at a point. Simple, we have done that. Electric potential at a point is the work done per unit charge in bringing a small test charge from infinity to point. Then we have the B part that says two parallel metal plates A and B are held a distance of d apart in a vacuum as illustrated in figure 6.1. Plate A is earthed and plate B. Okay, if you remember in our last video when I was explaining this chapter, I told you that first we have electric field strength for the point charge, then we have electric field, and then we have electric field for uniform field, and that is how it looked like. This is where it is plus V naught, and then it gradually decreases to become 0 volt. This is D, and this is where the point P is. So you can see this is a uniform electric field. So this is uniform electric field. And do you remember the formula for uniform electric field? That was E equals change in potential over D. So now it says plate point P is situated in the curved center region between the plates at a distance x from plate B. The potential at point P is V. Okay, so here it's V naught, then it becomes V. Okay. On figure 6.2, show the variation with x of the potential V for value from x0 to xt. Okay, so what they're essentially asking us to do is draw a graph. This is distance d and this is V naught. Now you do notice the fact that it was V naught here and then it becomes 0, so it is decreasing. First thing stated, gradient is decreasing. Now you may think that okay, the gradient can decrease like this or the gradient can decrease like this. How do we determine what is happening? So what I'll tell you something. Do you remember potential gradient? I explained it in last video as well. Potential gradient is the gradient of V by D that gives you the electric field strength. And do you notice the fact that this is uniform slash constant electric field strength? So when you have a uniform electric field strength and the gradient of this gives you the electric field strength, that means the gradient has to be constant. So it has to come where it's written D. You have to start from 0 V naught and then you have to bring it all the way straight line. You have to bring a straight line from here to this point, from till D, right? So the coordinates, they will be 0 V naught and D 0. So the reason why it's a straight line is because the gradient, this is called the electric field strength, and here it's written that is uniform electric field strength, so uniform gradient. Then let's move on towards the C part. Two isolated solid metal spheres M and N, each of radius r, are situated in a vacuum. Their centers are at distance d, and each sphere has a charge plus q. Okay, both of them are plus. That means we have two like charges. Okay, we have two charges. We have like charges. And point P lies on the joint in the center of two spheres, and the distance y from the center of sphere M. On figure 6.1, variation. Okay, so they're asking for the variation of potential against distance. What should come to your mind? The four graphs that we did. This. V against x, V against x, E against x, E against x. So these are the 4 graphs that should come to your mind. Now it's asking for potential again, so we can cut these out and we will be doing from these two. Now how do we narrow it down? This is for unlike charges, this is for like charges. So this is where you have the potential, this is where you have the distance. Now just always remember, when you have a particle and the distance for this radius, it is constant, it is uniform, it's uniform potential, so it will remain a straight line. So it's literally the exact copy of this. So it says R here. Let me make this a little above. This is Y. Now here it's written R, which means from 0 to R this is the radius, and then it's written D minus R, and then it's written D. So obviously we know that, and if you see the in the diagram above, if this is R, that means for this radius the electric potential, it will remain constant. You just draw a straight line like this, and you do the same here as well, because a D minus R minus D will give you radius. This is radius as well. So for the radius it will remain constant. Now what happens to this part? Exactly this that we have already done. We do it like this. So the reason why it's not touching the 0 or it's not going in the negative direction, because we did state that if both of them are positive, so it's like plus VA plus VB, so both of them are just reinforcing each other, it will never reach 0. And this is it for question number 6, and I hope that made sense.